So we are doing May June 25 paper 4.3 and we'll start from the first question. I have the source file here and the question paper. Okay, so first question is simple. It's a standard ADT question. They're saying you have to open the source file, which is called Q data. And if we go through it, it has some integer values, 46 lines. All right. Then they're saying that this is going to be a linear queue. Okay, so let's add the nodes here for our convenience. And then it is going to have 50 elements. And then the queue has the following pointers, head pointer and the tail pointer. So head pointer will store the index of the first element in the queue. And tail pointer will also store the index of the last element in the queue. Okay. So just an example, if we have a queue like this, so if we have values 10, 20, 30, maybe, and then we have some null values, empty indices. So the head pointer will be pointing to the first value, which is this, and the last value would be being pointed to by the tail pointer, like this. So it would not be pointing to the next available index, instead at the current index on which the values are stored. So they'll be initialized to -1. Okay, Q is a global array of 50 integers. All right, and we have to initialize it. So they're saying two pointers are declared as global variables and initialized to -1. So let's do that. We have head pointer is equal to -1, and we also have tail pointer is equal to -1. And then they're saying you also have to initialize Q, which is going to store 50 integer values. So we'll say Q is equal to -1 for I in range 50. And if we print the value of Q, so it should have 50 -1s. And it does. All right. Then in the next part, they're saying you have to write the function nq, and so we can get rid of this. So we have to write the function nq, define nq. This will allow you to input a value into the queue. So let's call it item. Okay, now they're saying take an integer input, and that will store it in the next position, and then return false if the queue is full. Okay, so let's just for this example assume that we have three values. Okay, so when we have three values, since the question said that the tail will be pointing to the last element in the queue, so the tail is also going to be 3, right? It would be in fact 2, so this would be index 0. So if I write the indices, this would be index 0, 1 and 2. Now when tail becomes greater than 2, yes, so that means that the queue is full. So in this case, the logic would be as soon as our tail becomes greater than the size -1, or we can just say as soon as the tail becomes equal to the size of the queue. So this would be when tail becomes equal to 50, when we'll say the queue is full, or simply we can say when tail is greater than 49, because that is the same logic. When we have three values, tail is pointing to 2. When we have 50 values, tail is pointing to 49. And when it becomes greater than 49, then the queue is full. So we have to use the same logic here. So let's see if the tail pointer is less than 49, then that means that we have enough space in the queue, and so it should be,
Shouldn't less than 50?
yes, this should be equal to when tail becomes greater than, okay, so when the tail pointer becomes greater than 49, then that means that the queue is full, so we'll return false directly. Else, if that is not the case, okay, then we're going to return true, and we're going to store the position in the next position in the queue. Okay, so we're going to store the item. So we'll say we'll first increment the tail pointer by 1, so that it points to the next available space. So after 30, maybe we have some space, let's call it x. So tail will move to x, and then we'll put a value there, and then we'll store q index pointed to by tail pointer. We'll store the value of item, and we also need to globally access these. So global head pointer, tail pointer, and q. Okay, and then okay, so this is a linear queue. Now there is one check that we need to add. This is a very common mistake in the exam, that is when we initially input a value into the queue, So let's say if there's no value in the queue, so head is set to -1 initially, okay? So when we add a new value, let's say the value is 99 or 90, so tail will get pointed to 90, but the value of head does not change. It still points to -1, which is wrong. So what you have to do is whenever you insert a value into the queue, and if the queue is initially empty, you have to make sure that you set the head to index 0 as well. And tail would already go to index 0 because we have the incrementing procedure in place for the tail like this. So now head and tail both are pointing to index 0. And that would only work when the queue was initially empty. So here we'll add a check. If at any point head pointer becomes equal to -1, then we're going to set the head pointer to 0. Why? Because now there is one value in queue. And then after this, we are going to return true at the end. So this is the enqueue function. Okay, then they're saying that the dequeue function. So let's quickly go do that. So define dequeue. And for dequeue, they're saying returns the next item in the queue if the queue is not empty. Okay, again, so going back to the example, let's say you have 90, 100, 150. So head is pointing to 90 maybe. And tail is pointing to 150 like this. So when we are going to dequeue the value, they're saying returns the next item in the queue. So basically we are supposed to return the value um, that is being pointed to by the head, and then we are going to increment it, and then we are going to go to the next index. So now head will point to 100, and then we'll return the value of 90, which was dequeued. Okay, so this is fairly simple. First of all, let's globally access all of these, and then we check if the value. So they're saying return check if the queue is not empty and return -2 if the queue is empty. So when would the queue be empty? So the queue would be empty if the head pointer is equal to -1. Right? So we'll simply return -1. There is no other possibility where the queue would be empty. Okay, else if that is not the case, if the queue is um, there are some values in the queue, so we have to update the pointers. So in that case, what we have to do is again, wherever the head pointer was pointing to, we'll store that in a variable. So let's call it dequeued. We store it, we decrease the function name, let's call it deleted. Deleted is equal to wherever the head pointer was pointing to. So queue index head pointer. So we get this value, which is 90 in this case, because head was pointing to 0. Then we increment the value of head pointer by 1. So head goes on to point 200, and then we return the value of deleted. So return deleted, and that is it. So this is the dequeue function. Okay, we'll hide this as well. Then they're saying that in part D, we are supposed to create a procedure called define create queue, and it will access some values. Okay, so open the file queue data and read in each line from the text file and use enqueue. Okay, so let's try that. So whenever we have file handling, we'll always do try catch. So try, and we'll say f is equal to open. The file is queue_data.txt in read mode, and we eventually have to close the file, and then we'll need to loop. So for line in f, print line dot, or in fact, let's just store it in some variable. So item is equal to this, and then let's print the value of item. Okay, if that is not going to work, then we are going to generate some exception. So file processing error, and it's not going to work unless we call it. So I'm going to do that again. This is not part of the question, but we'll just do it to make sure that it is working correctly. So create queue. Okay, we are getting all the values. We should still check quickly. So first value is 15, last value is 54. First value is 15, last is 54. Yep, this is correct. So it's working fine. That means we have read the values from the file successfully. Okay, then they're saying that you need to read each line, and you have to use the enqueue function to store the values into the queue. Okay, so we are getting this item here. We don't need to print the item right now, so I'll comment this. Instead, what we have to do is we have to call the enqueue function. So we'll call enqueue and we'll send in the value of the item. Again, you don't necessarily have to use the same names here. I just use them for convenience. Okay, so once we enqueue the value, they're saying output queue full if an item cannot be added into the queue. So let's get the response from the enqueue function, and we know that enqueue is going to eventually return false if the value is not stored. So I'll check if the response becomes equal to false, or I can just write if it's not true, which is false, then I'm going to print that the queue is full, and then I'm going to return anything. No, there's no return, so we'll just output and we'll break the loop here because we don't want to read further. Even if you skip this break, it's completely fine. And we have to open the close and needs to work a file that contains an unknown number of lines. Okay, so we have done all of this. All right, and let's go ahead and try this as well. So yes, there is no error. We have 50 values in 50 spaces in the queue, and then we have like 46 values in the file, so that it should not give you any error, and that is fine. In fact, just for test purposes, we should print the item added in queue, something like this, just for. Okay, so it will print all this. Okay, so it will make sure that all of the values have been added, and then you can simply ignore this because it's not part of the question. Okay. All right, in the next part, they're saying the main program needs extending to call the create queue. The main program then adds together all of the integers stored in the queue using dequeue and access each integer. The total is then output. Okay, so what we have to do is these values that we read from the file, all of these values, we are supposed to get them out of the queue one by one using dequeue, and we're supposed to add them all together and print their sum. So this is fairly simple. Okay, so we're going to keep calling dequeue until what? Until it returns -1. And when it returns -1, the loop will end. And as long as that is not the case, we keep on it dequeuing the value and we keep on totaling them. So that is the question. So let's have here q sum is equal to 0. And then we have, let's call it response, which is equal to 0 initially as well. Or maybe, so this will return you -1. Okay, so maybe we can take this input as well. int input, enter. Right, we don't need the input in this case. Okay, so we can just set it to 0 because we just need to run the loop once. Okay, so while response is not equal to -1. Okay, as long as it is not equal to -1, which means that q is not empty. And then every time we are going to dequeue a value, so response is equal to dequeue. So the reason we set response here is just to initialize it, so the loop will run. Okay, so you can give it any other value which is not equal to -1 and it will still run. So this is just to make sure that it runs once, and then we'll dequeue an actual value from the queue. Once we have dequeued it, then we are supposed to check if it is not equal to -1 again. Because if it is equal to -1 at this point, then we're not supposed to add it into the total. And then we'll say q sum plus equal to the response value. And once this loop ends, we'll print the whole value. So sum of values would be q sum, like this. And that is it. And then they're saying to test it.